Hi guys, so in this video I am going to be going through some extra literal equations examples because I know that these can be super complicated, super abstract, so I want to give you guys a resource that you are able to look back at any point. Okay, so right up top, these are our steps for a literal equation. The first step, we need to figure out what variable we are isolating. And like I said, y'all know I love my colors. So the first thing, I always like to highlight what variable I'm getting by itself. Okay, just so it's extra clear, since we have so many different letters going on, I really want that one that I am isolating to stand out. Okay. Second step is we are going to use inverse operations to isolate the variable. So that's just exactly what we were doing when we were solving our multi-step equations. Like, what's the opposite of addition? Subtraction. What's the opposite of multiplication? Division. All that good stuff. And the third thing is, when you are using those inverse operations, treat all other variables just like numbers, just like we had been doing with our multi-step equations. Okay? So, this first example, I believe there are 10 in total. We want to solve for y. So I'm going to go ahead and just highlight that y so I know what one I need to get by itself. So our first step, before we can do anything, we have this gigantic division by 4, right? That's what that big fraction bar is. And so what we want to do is we want to get rid of this fraction before we can move our y or anything else, right? So to undo division, we have to multiply both sides by 4. Okay, so like this and that would cross off. So we're left with 2x plus y equals 4. Our next step in getting that y by itself is we want to get rid of this 2x. This is just a positive 2x, right? So to get rid of a positive 2x, we subtract 2x from both sides. So we get y equals negative 2x plus 4. This second example, it is the same equation, but this time we want to solve for x. Okay. So we are going to have the same first step. We need to get rid of this gigantic fraction. So again, we're going to multiply both sides by 4. So those cancel. We get 2x plus y equals 4. Again, we're isolating that 2x, so we need to move our plus y. To have a plus y, we subtract by y. So we get 2x equals negative y plus 4. To get rid of our coefficient, the operation that's really happening between our coefficient and our variable is multiplication. So to undo multiplication, we divide both sides. So this leaves us with x equals negative y plus 4 over 2. Or if you want to go the extra step of splitting up our fraction, that's going to give us negative y over 2 plus 2. Okay. These are both acceptable answers. Okay. Whatever floats your boat is what I want you to do. Okay. All right. Number 3. We are solving for y in this example. So what we're going to do, we draw our line down the middle just to keep things extra clear of what side we're working on. So we need to move this one. We're going to do this in 2 steps. We're going to make this one quick. We're going to combine some things. We know that we want to get this y by itself. Okay. To move the y, to get the y alone, we need to get rid of this minus 6x as well as the plus 9. So I'm just going to move both of them at the same time. So to move a minus 6x, we add 6x. To move a plus 9, we subtract 9. And we do this to both sides of our equation. So those cancel. we're left with 3y equals 6x plus 12 minus 9. But we notice we have some like terms that we need to combine, right? That 12 and the negative 9. That leaves us with 3y equals 6x plus 3. Our last step is always to get rid of our coefficient. So we divide by 3. So we get that y equals 6x plus 3 divided by 3. Again, or if you want to break that up, that is 2x plus 1. Okay? Right. Number 4. This time we are solving for w. Grab the wrong green highlighter. Hopefully this formula looks kind of familiar. This is a volume of a like rectangular prism formula. So we want to get this w by itself. So there's kind of two ways we can go about this. The first way is, I'll go ahead and I'll do them to two separate ways. So we have v equals L WH, and we want that w by itself. We know that the L is being multiplied, so we can divide by L. Okay, that goes away. So we get v over L equals WH. We know that H is also being multiplied by the W, so we have to divide both sides by H, except this is really messy right here, right? Like this is, we have a fraction being divided by another fraction. So you would have to know that when you're actually dividing by a fraction, you're multiplying by the reciprocal, and it's this whole big mess, right? So this is really v over L multiplied by 1 over H, because another way of writing this is v over L divided by H. That's the relationship between dividing by a value and multiplying by the reciprocal equals W. If we clean this up, we get V over LH equals W. Okay. The other way to do it, which I would highly recommend since that gets pretty wonky, is we know that multiplication is commutative, meaning 2 times 3 times 4 is the same thing as 3 times 2 times 4, okay? It doesn't matter what order the terms are in, it's still going to be the same. So we can rewrite this, if it helps us visualize a little bit better, as LH times W, so you can clearly see what our coefficient is. And like any coefficient, we're going to divide to get rid of it. So you get that V over LH equals W. See, this one clearly had a lot less steps, but again, whatever works best for you, I would just be very cautious of going about it this first way. Okay. All right. A few more examples just because I want you guys to see as many as possible. All right. Number 5, we are solving for H. Hopefully this is a formula that you recognize as well. This is the area of a triangle. So we want to get H by itself. Something that I would really recommend doing, this 1/2 B, this can really be rewritten as B over 2. Okay, so this is A equals B over 2 times H. Okay. And to get rid of our coefficient, we divide. Divide by B over 2. And again, we're in that same sort of sticky situation as before, where we're going to have to use our reciprocal. To this day, I struggle with this concept, so what I like to do, I like to go off to the side and rewrite it as, all right, it's A divided by B over 2. So to write that using multiplication, it's really A times 2 over B. And in that, I can work with, right? This is really a over 1. And we just multiply across the top and across the bottom. So we get 2a over b equals h. Okay, so familiarizing yourself with this concept of how we go between division and multiplication with reciprocals, right? Reciprocal is just when we flip it. This is going to slowly become a more important piece of this class. Okay, number 6. We are solving for h. Okay, this one looks lengthy, but it's probably really not too bad. So, our h is what we want to get by itself. And I am going to do this in just one quick swing. So, we have a plus 2L and a plus 2W. To get rid of both of those, what we're going to have to do is we subtract. So we're going to do minus 2L minus 2W from both sides. Okay. On our right hand side, both of those go away. So we're just left with equals h. On the left, we have p minus 2L minus 2W. And that is it. If you want, by all means, you can go term by term. But since we are, the only time you can kind of do multiple things at once is if it is all addition and subtraction. Okay, that's the only time where you can do multiple sort of moves at once. If you have multiplication and addition, no, those need to be very, very separate. Only when it's the same operation can you do multiple steps in one. Okay. So, number 7, we are solving for k. So our first step, so we need to get rid of this positive y. So we're going to subtract y from both sides. That goes away. We get w minus y equals k over 2. And the way we get rid of division, the opposite of division is multiplication. So we multiply both sides by 2. So we get 2 times w minus y equals k. If you want, you could distribute that 2 in. So you get 2w minus 2y equals k. Again, these are the exact same thing, so I will accept either answer. Okay, that's kind of the neat thing with these, is there are multiple representations for a lot of these. All right. Number 8, we are solving for y. Also, let me make this a little clearer. This is a z, not a 2. So, again, we want to get that y by itself. So we need to get rid of our plus 2x by subtracting 2x from both sides. That gives us z minus 2x. That goes away. We're left with negative 4y. To get rid of our coefficients, we are going to divide. So I'm going to come off to the side and give myself enough space for this one. We get y equals z minus 2x over negative 4. And if you were to break this up, we'd get negative z over 4 plus x over 2. Okay. Right, 2 more examples. And hopefully this sort of cleared up any questions y'all were having. So this one we are solving for a. Our first step in getting a by itself, we need to move this positive 12. So we'll subtract 12 from both sides. This gives us negative 6a equals 18b minus 12. Our last step is to divide by negative 6 on both sides. So we get a equals 18b minus 12 divided by negative 6. And if you wanted to rewrite that, that actually simplifies really nicely to negative 3b plus 2. And our last example, we are solving for x in this one. So, first thing we want to do is we need to get rid of this multiplication that's happening on the outside. So to get rid of multiplying by 3/4, we're going to use our reciprocal. Okay, so let's see. To get rid of this multiplying, we can divide by 3/4. Divide by 3/4. But we know that dividing by that fraction, we know that y divided by 3/4 is the same thing as y times 4/3. So this gives us 4y divided by 3 equals x minus 10. Our last step for this one, since we don't have a coefficient, is to get rid of this minus 10 by adding 10 to both sides, so that our final equation looks like x equals 4y over 3 plus 10. Okay. Hopefully this video cleared up any questions you guys were still having about literal equations.